Have you ever heard of antimatter? It is one of the strangest and most complex physical phenomena in the universe. How does antimatter form, and what are the major challenges facing physicists in producing and storing it? Let's dive together into the world of antimatter and explore the secret of this rarest matter in the universe. In the beginning, this is how any substance in the universe consists of very small things called atoms. Those atoms consist of a nucleus and electrons that revolve around it at a very high speed. That is, electrons that have a negative charge. The atom nucleus consists of other particles called protons, which are positively charged particles, but in antimatter it is completely different. Antimatter are tiny particles that have an electric charge opposite to the charge of the electrons in the atom. They are also called antiparticles. They are formed when energy and mass combine to convert energy into matter, including antimatter. The most expensive matter in the universe is the rarest and heaviest antimatter, called antihelium-4. This matter is made of antimatter particles, which are similar to ordinary helium-4 particles, but are made of antimatter instead of ordinary atoms. Antimatter is usually produced when two paths of energy collide, and this matter combines with ordinary matter to form new atoms and release energy. Antimatter is the heaviest and rarest substance in the universe, making it the most expensive substance in the universe. Antimatter in the universe is produced naturally through the processes of radioactive decay of atomic nuclei and during cosmic explosions such as massive stellar explosions and natural nuclear explosions. However, the rarer and heavier antimatter does not form in sufficient quantities to be used for practical applications. Antimatter is widely used in scientific research, as it is used to study particle interactions and to determine the physical properties of matter. It is also used in many medical imaging applications such as positron emission tomography, where radioactive antimatter is inserted into the body and then interactions between particles and tissues are monitored to generate accurate medical images. It is also important to note that the production of antimatter requires very advanced and expensive technology, as it is usually produced in nuclear physics laboratories using high-energy particle streams. The heaviest and rarest antimatter in the universe is considered among the most expensive materials in the world because of its difficulty and rarity in production. Producing and storing antimatter presents significant challenges because it is highly unstable and reacts with matter almost immediately upon contact. One of the main challenges is the production of antimatter in sufficient quantities. Antimatter can be produced in particle accelerators, but the process is very expensive and requires a lot of energy. The yield of antimatter is also very low, as it is produced in minute quantities and quickly annihilates when it comes into contact with matter. Another challenge is the storage of antimatter. Antimatter must be contained in a vacuum and away from any matter, as even a tiny amount of contact with matter can cause the antimatter to annihilate. This means that antimatter must be stored in specialized containers that can maintain a vacuum for extended periods of time. Additionally, the containers must be made of materials that do not interact with antimatter, which limits the choices of materials that can be used. The transportation of antimatter is also a challenge. Antimatter cannot be transported like other materials and requires specialized equipment to ensure that it remains stable during transit. Any contact with matter during transportation could lead to the annihilation of the antimatter. Overall, the challenges of producing and storing antimatter make it a very expensive and difficult process. However, advances in technology and research may lead to improvements in these areas, which could make antimatter more accessible for research and potential applications in the future. And this is how we finished today's video. Do not forget to subscribe to the channel and see you soon.